SpaceX Raptor is introduced as a reusable, powerful engine that will power the Starship launch system to colonize Mars. This is something that's never been done successfully before. And there's the fact that SpaceX has not achieved it either. The problem can only be summed up in two words: reusable, powerful. Let's discuss everything about this in today's episode of Alpha Tech. Let's talk about powerful first. You'll probably see this clearly. It took the FAA more than a year to review the impact of the Starship flight. NASA worries SpaceX's Starship could destroy its launch pad, and SpaceX hasn't simultaneously tested 33 Raptor engines. A single Raptor 2 produces 510,000 pounds of thrust. To compare, F1 engine had 1.5 million pounds of thrust. But the most important thing is with all 33 Raptors at full throttle, Starship is producing 7,600 tons or 16.7 million pounds of thrust at liftoff, beating the most powerful rocket. Saturn V uses 5 F1 engines in the first stage. Its power is extremely barbaric. You know, Rocketdyne has designed the F1 engine for several years, and they did that before for the U.S. Air Force. But after the Air Force couldn't find a use for the powerful engine, development stopped until NASA came along. And SpaceX has been definitely facing many tough issues with dozens of Raptors on Starship. Now let's turn to the other word. One definition of a reusable rocket engine is simply one that can be fired more than once in succession. Pretty much all the legacy-era engines that people discuss meet this criteria. The fact is that even non-reusable engines are often kept on test stands for months at a time as part of the development or certification test or acceptance efforts that are all designed to accomplish one thing or another. It's by no means unusual to have several dozen test firings on a single non-reusable engine. So what are the challenges in making a Raptor engine and giving it a long life and making it truly practical to operate over that long life? Honestly, anything that's required to work repeatedly in extreme conditions is more difficult to do than something that's only required to perform for a few minutes, which is the typical runtime of an orbital booster. The biggest and most troublesome component is the turbopumps. Most rocket engines are an open cycle design where fuel and oxidizer are bled off the main system to drive a twin centrifugal pump via turbine. The exhaust from that process is dumped outside the engine bell and can be seen as a trail of black smoke, as they're usually designed to be very fuel-rich. Being fuel-rich helps keep temperature down, but even so, the turbine blades and seals are still subject to high temperature and stress, which can destroy fine tolerance components quickly. More sophisticated designs like the SpaceX Raptor use a fully closed cycle system, which actually has an individual turbo pump each for fuel and oxidizer. Going for a fully closed cycle means the engine is more efficient since all the fuel and oxidizer are sent to the main combustion chamber and nothing is wasted. That means one of your turbo pump turbines has to run on a lean mixture, greatly raising the combustion temperature. Until recently, the Americans thought it was impossible, although the Russians had perfected the material technology to withstand the temperature for years in those RD engines. Either way, you need to have a very highly stressed bearing, shaft, and seal that can withstand some extreme conditions repeatedly. Another consideration is the need for reusable rocket engines to restart, which is not often a consideration for a single-use engine. This involves extra complexity, which means more things can go wrong. This doesn't even begin to look at the bell design, which has to be capable of withstanding the combustion temperature that's generated within the main chamber without cracking. Once again, the more heat expansion and contraction cycles the bell has to go through, that means yet more investment in material and design. Basically, we're talking about a machine that has to work at the absolute limit of the material used, using the minimum amount of mass, and still be in serviceable condition after a flight that might require several start-stop cycles. Then another important thing is the difficulty of getting the engine back to Earth in any usable shape at all. SpaceX plans to catch Starship with Mechazilla towers, but as explained many times, this is more insane stuff. The Space Shuttle's Solid Rocket Booster, or SRBs, were labeled as reusable. To enable this reusability, 3 large parachutes were used to lower the SRB gently to the ocean. In fact, things were considerably different. The SRB splashed down in the ocean on its aft skirt. It so happens that the majority of the high-dollar SRB hardware is in the aft skirt. This is where the guts of the SRB flight control system are located. The required impact velocities were computed so as to not impose overly large loads on the SRB hardware. On the first flight, STS-1, upon recovery and disassembly of the SRBs, the entire contents of the aft skirt of both SRBs were found to have been destroyed by the splashdown load. This phenomenon repeated itself on the second and third flights. The fourth flight lost its SRBs due to a recovery system failure. The loss of this hardware on every single flight was not allowed for in the shuttle program's budget, so considerable effort was put forth to try to figure out what's going on here. More than one distinguished Tiger team was formed to solve this problem once and for all. Sadly, none of the vaunted Tiger teams made any significant progress at all. The source of the very high splashdown load remained mysterious. There were stopgap measures put in place to protect the SRB flight control system hardware from a very high splashdown load, but the return on that effort was modest at best and cost an enormous amount of time and effort in ground preparation prior to the flight and SRB disassembly after the flight. Even when SpaceX brings Raptor back successfully, the question comes about, how is a reused engine going to be flight certified? It turns out that's a tricky question. If the criteria for flight certification for a reused engine is the same as that of a new engine, it implies that all of the same tests starting at component level are performed as they would be for a new engine. You've probably heard a lot of stories about the Space Shuttle main engines, SSMEs, having to be rebuilt between flights. Many of these statements are untrue, but it's true that the inspections required of an engine were numerous, and we often erred on the conservative side, such as replacing a component when the results of an inspection were ambiguous. NASA then ran vicarious checkout tests on the components that were replaced and ran a series of full-up simulation tests on the entire engine, which fairly well duplicated the initial checkout test for that engine. The COFR for the SSMEs could then be signed based on the subjecting of the reused engine to essentially a full set of new engine checkout tests. The above description was an attempt to explain how NASA made the SSME formally reusable. In summary, the engine's fully capable of numerous firings to begin with, and so is reusable without adding further trimming. However, the flight certification process that accompanies a reused engine had to be conducted to the same standard of rigor that's applied to a new engine. And finally, when people think about reusable engines, it means less expensive. Actually, that's entirely false. In fact, the shuttle program results can be used to argue that reusing space hardware is actually more expensive than building new hardware if the flight certification standards for reused hardware are the same as for new hardware. The hard part of space hardware that's expensive is not the aluminum, steel, and nickel that sits on the launch pad. The costs for this part are all but in the noise. The expensive part of the proposition is the size and technical capability of the workforce that's required to comply with traditional flight certification process and maintain the ability to launch on schedule and with minimum schedule slippage in the event of a problem. After all, SpaceX engineers are now applying more modern scientific research. However, overcoming all these difficulties is not possible in the near future.
It will work. Might be a few bumps along the road, but it'll work.
Space is hard and unforgiving. It always has been and always will be, excluding no one. Now on the way to orbit, the biggest private rocket company, SpaceX, is facing a huge problem with Raptor engine testing. What's making things so hard? Can Elon Musk get Starship out of this difficulty and get it into orbit? SpaceX CEO Elon Musk has his mind set on going to Mars. To do so will require a vast new spacecraft powered by a new rocket engine, unlike anything that's been seen before. Step forward, Raptor, the future of SpaceX's endeavors. Raptor definitely represents a large shift in SpaceX ambitions from modest Earth-based launches potentially to the exploration of the solar system. The engine's been in development for the better part of a decade, going through a number of iterations. At its core, like other engines, burning chemical fuel to produce thrust. But its use of liquid oxygen and methane, something largely unprecedented in the rocket industry, and its innovative design means it just might be SpaceX's ace in the hole when it comes to exploring the solar system. However, achieving that greatness is never easy. Raptor is always a big problem that SpaceX has to struggle with. Before the breakthrough of SN-15, SpaceX went through a series of failed tests in a row. SpaceX's Starship SN-8 prototype exploded during a crash landing after a 6-minute, 42-second test flight from its Boca Chica, Texas test site on December 9, 2020. The SN-9 prototype also crashed and exploded during landing after a 10-kilometer test launch from the company's South Texas facility near Boca Chica on February 2, 2021. The SN-10 rocket prototype had a successful liftoff and soft landing at the company's South Texas launch site on March 3, 2021, but it then exploded as well. On March 30th, SpaceX's Starship SN-11 lifted off in a thick fog, only to meet a similar fate to its 3 earlier iterations. The cause of these failures was more or less related to the Raptor engines. To clarify, remember that Elon Musk, after SN-11's flight test, wrote that Engine 2 of the 3 Raptor engines on SN-11 experienced problems during ascent that only got worse when it reignited for the landing burn. Thus, it's clear that Raptor has long been plagued with problems. At the end of last year, SpaceX CEO Elon Musk even sent an anxious email to his company's employees, urging them to work over the weekend on the SpaceX Raptor engine line and describe the production situation as crisis. Previously, 2 members of SpaceX leadership left the company. They left Raptor production due to lack of progress, sources said. In recent months, as the whole world looked forward to the first orbital flight day by day, the failures in Starship's Raptor test has become more and more obvious. The proof is the arduous journey of Booster 7. On July 11th, what might have been a partial wet dress rehearsal, a dispersed cloud of methane gas found an accidental ignition source and exploded with a force that at least one observer estimated was equivalent to several pounds of TNT. Booster 7 was back at the factory for repair after that point. After that, Elon Musk also admitted that going forward, we won't do a spin start test with all 33 engines at once. Earlier last month, SpaceX continued to perform 2 static fires with Booster 7 on the orbital launch mount. Both of those tests involved just one of the vehicle's Raptor engines. On August 31st, the company upped the ante, lighting 3 Raptors on the prototype Super Heavy for about 5 seconds at 2:03 p.m. Eastern Daylight Time. But only 2 engines may have fully lit up, with the third perhaps aborting. Furthermore, according to the NASA spaceflight video, there are many Raptor engines self-destructing during testing. Honestly, there's many ways that can lead to engine failure. Combustion chamber, LOX turbo pump, the CH4 turbo pump, pre-burner failure, or external leak fires. There's also a big problem in heating and testing. The combustion chamber of a Raptor 2 is exposed to a gigawatt of heat. That's enough to melt every known material. To stop these engines from melting takes some serious engineering, like pumping cryogenic fuel around the engine to cool it. But these systems are difficult to tune and perfect. That's why Raptor 2s are still in test phase. The rocket's undergoing static fire tests to see how well it can keep cool and if it can sustain a burn for long enough, while retaining a long life cycle and being able to do several launches before needing to be replaced. Until SpaceX nails that, it can't put a Raptor 2 into orbit. The use of methane also creates more difficulty for SpaceX engine testing. You know, no methane-powered rocket has ever made it to orbit, and Raptor also uses what's known as a full-flow stage combustion engine, only the 3rd engine in history to employ that technique, whereas Merlin uses more common open-cycle systems. The previous 2 attempts at such an engine, one in the Soviet Union in the 60s and another in the US in the early 2000s, never got beyond testing. A full-flow stage combustion engine refers to how a pump spins a turbine to drive the engine, using what's called a pre-burner to get the process going by injecting a small amount of fuel. Normally, some of the propellants are expended in a traditional open-cycle engine to start the process, but Raptor will use every drop of propellant available, making it one of the most efficient rocket engines ever built. SpaceX isn't the only company moving to methane, as rival firm Blue Origin, headed by Amazon CEO Jeff Bezos, is also developing its own methane engine called the Blue Engine 4 or BE4. However, they also are encountering a lot of trouble. We can clearly see that when looking at the number of delivery delays. Ultimately, because the Raptors plan to be reused, this adds even more complexity to the SpaceX engineers. When a typical first-stage rocket engine finishes its job, it would be traveling several times the speed of sound, above most of the atmosphere, somewhere hundreds of miles over the ocean. Getting the engine from there back to where you can reuse it without adding an unacceptable amount of weight is actually rather difficult. Flying back to land on wings adds a lot of weight and complexity, and it requires you to reserve a fair amount of fuel if you're doing a SpaceX-style flyback boost. You could drop the stage into the ocean with parachutes, but then you're dunking your engines in salt water and you have to send a ship out to pick the whole thing up. And safely landing something the size of a rocket stage by parachute, it's actually pretty difficult. And second and higher stages have it even worse. You'd have to recover them from traveling at close to orbital speed. You'd need a serious heat shield to survive re-entry on top of all the difficulties of landing it. Too complicated, right? Well, in short, all of this really causes the SpaceX Raptor to explode so often. But Elon Musk is clearly not giving up on his chosen path. Let's hope and let's see. Elon Musk is an absolutely ambitious man. To service enough batteries for Tesla cars, he's willing to open 2 huge battery factories in Nevada and New York for 2 consecutive years. And now he's building a second Raptor factory in Central Texas, which will be the world's most advanced rocket engine factory. SpaceX's engine testing facility on 4,300 acres of land in McGregor, Texas, just south of the city of Waco, is undergoing new development and testing related to the Raptor engine for Starship and Super Heavy. With 5 test bays, the facility will soon become a hub for Raptor 2 engine assembly, with a factory now under construction. This is taking place as Merlin engine and stage testing related to the upcoming Falcon 9 and Falcon Heavy flights continue. Interestingly, the McGregor facility originally was not an engine factory and wasn't built by SpaceX, but it has a long, brilliant history. All the way back after Pearl Harbor and the entrance of the U.S. into World War II, production increased dramatically at home to aid the war effort overseas. In short, munitions factories popped up throughout the nation, and McGregor, Texas was chosen as one of those sites. This site was to be known as the Blue Bonnet Ordnance Plant. The munitions plant started the production of bombs on October 16, 1942. Just like how SpaceX is transforming Boca Chica and the surrounding areas, over 1,100 automobiles and trucks went to and from the plant each day, taking workers to and from the plant. And this place became crowded. Many of the workers at the plant were from out of state and even out of the region. Once the war was over, though, the factory was no longer needed and production was shut down soon after. After the war, the facility was converted to support the development and manufacture of ammonium nitrate-based solid rocket propellants and opened by a number of successive companies. Phillips Petroleum from 1952 to 58, Astrodyne 58 and 59, Rocketdyne from 59 to 78, and Hercules from 78 to 95. In 1995, Hercules transferred their operations to the Allegheny Ballistics Lab in West Virginia, ending the manufacture of energetic material at the site. After being handed back over to a munitions company for about 20 years, the facility was finally taken over by an up-and-coming private space company looking to develop heavy-lift vehicles. But this company wasn't SpaceX. Set up in 1997, Beale Aerospace came before SpaceX and took over the McGregor site, acting as a testing facility for their rocket engines. In the year 2000, they successfully test-fired their BA-2 engine, the largest rocket engine made since the Saturn V's enormous F-1 engine. However, later that year, the company closed down after NASA decided not to invest in them, so the McGregor facility was once again left empty. Next in line, though, was SpaceX, who took over the site just 3 years later to begin testing the Merlin engine, which was to be used on their Falcon 9 rocket. And now, to support growing needs of Starship and Super Heavy, SpaceX is building the most advanced rocket engine factory in the world in Central Texas by itself. Musk said the new engine production factory would be in McGregor because of challenges at the South Texas site. He didn't give details. The challenges of operating at Starbase left us with no choice but to put engine production in McGregor, Musk tweeted. Last year, Musk said in a Twitter post that he lives primarily in a Boca Chica home worth $50,000 that he rents from SpaceX. He previously said he moved to Texas to be closer to 2 of his biggest focuses, SpaceX's South Texas facility and the Tesla facility currently being built in Austin. The billionaire also said he intends to use the new engine production facility near Waco to help fuel his plan for a city on Mars by 2050. Musk said the engines will be needed for a fleet of rockets to be used over a 10-year period to create the city, which he predicts will take about 20 years to build. That's about what's needed over 10 years to create the fleet to build a self-sustaining city on Mars. City itself probably takes roughly 20 years, so hopefully it's built by 2050, Musk wrote. If all goes according to plan, that facility could also become the highest output rocket factory ever built, churning out hundreds of Raptor engines every year to outfit a vast interplanetary fleet of starships and the Earth-bound super heavy boosters that would send them on their way to Earth orbit, the Moon, Mars, and beyond. According to Musk, a new cutting-edge SpaceX factory located at the company's expansive McGregor Texas rocket development and testing facilities factory will ultimately mass-produce between 800 and 1,000 Raptor 2 engines per year. Raptor vacuum production will remain at SpaceX's Hawthorne, California headquarters, alongside work on mysterious new experimental designs. Under the new paradigm sketched out by Musk, Raptor would mirror SpaceX's Merlin engine family, comprised of two colonize sea level and vacuum variants, Merlin 1 and Merlin Vacuum, for more than a decade. With just a single high-volume variant required, Raptor 2 production could be extraordinarily efficient and would easily outpace any other large liquid engine production in history at 800 to 1,000 engines completed each year. Technically, at its peak in the 1970s and 80s, the Soviet Union was producing hundreds of R-7 or Soyuz booster engines annually, and upwards of 1,000 plus per year if one counts the several different kinds of engines on each R-7 Soyuz booster. However, the annual production of a single variant of any other large liquid rocket in history has never come close to the target set out by Musk for SpaceX's Raptor 2 factory. The idea seemed crazy, but Musk is actually serious about it. In fact, Elon Musk has had lots of experience with similar projects. He lived through the production hell at Tesla in 2017 and 2018, building factories, changing processes, spending many sleepless nights, and going through all manner of mental agony. Luckily, the rewards are well worth the effort. Now, Tesla's Giga Shanghai reaches a massive production speed of up to 2,000 vehicles in a single day. Extremely impressive, isn't it? Musk then applied the well-worth lessons learned from Tesla's assembly line to SpaceX, and that helps their workers not burn out. They'll work 3 12-hour days and then have a 4-day weekend. Then they'll work 4 12-hour shifts with 3-day weekends. Thus, with 4 shifts, Boca Chica can operate at full capacity 24 hours a day, 7 days a week. SpaceX is throwing in hot meals every 3 to 4 hours for free. For now, the company's simultaneously building Starship and Super Heavy prototypes and conducting ground tests at the launch site. They've already performed multiple flight tests since 2019 and are preparing to conduct the first orbital test flight with a fully stacked Super Heavy Starship. 2.5 years since the first time Musk shared a photo of the first Starship, SpaceX has so far built Starship serial number 29 and Super Heavy booster serial number 11. The stacking of a flagship from start to finish right now takes around 3 months. Pretty impressive, huh? Well, having said that, no space company can beat SpaceX in rocket manufacturing speed. Local leaders are enthusiastic about the jobs and tax dollars that the SpaceX facility and the new rocket factory are bringing. The current McGregor facility employs 500 workers, and many more would likely be needed for the new factory. That just about wraps it up for today's episode. Don't forget, share your ideas in the comments section because your support is motivation for us to create more quality content. Thanks. We'll see you next time.